Hey girls, so on Monday at lunchtime we'll have probably our last lesson on polynomials for now at least, and then we'll do 2 harder 3-unit morning lessons. And the lesson on Monday will be on partial fractions, and I want to show you what that is. So partial fractions is all about integration basically, and the idea is that if I asked you to integrate this, let's just make an example. You don't know how to do that, basically, because the derivative of the bottom is not the thing on the top, and so it doesn't work. So what I need to do is I basically want to decompose that fraction into 2 other fractions. So I'm kind of doing exactly the opposite of making a common denominator. And I do that by saying, let's make it a on x plus 2 plus b on x plus 1. Okay, and I'll explain, well, you'll see in a minute why the thing on the top must be of degree 1 less than the thing on the bottom. So I've got a linear thing on the bottom, so that means the thing on the top must be just a number. And if I had a quadratic on the bottom, then the thing on the top must be a linear thing. It might be a linear thing that actually turns out to be a constant, but the point is it could be linear. So now I combine the 2 fractions, so I get a bracket so all I'm doing here is just algebra, all over x plus 2, x plus 1, and the idea is that if this fraction that I've just written down is the same as this fraction, since the denominators are the same, the numerators must also be the same. So if I expand the top, I get a plus b lots of x plus a plus 2b, and that must be 4. And then I compare coefficients. Okay, so this must be 0 because there's no x over here, so a must equal minus b, and these 2 things must be the same, which means that if I sub in this condition here, it means that b must equal 4, and then a must equal minus 4. And then I would sub it back into the integral, and the integral can now be written as minus 4 over x plus 2 plus 4 over x plus 1, which I can integrate because it's just a log plus a log. That's what partial fractions are. So I'll show you one more quickly. So let's just, and I'm just making these up, so I might actually not finish this one. But let's just say, for example, that I wanted to partially decompose x plus 1 over x cubed minus 8. So that's the same as x plus 1 over x minus 2, x squared plus 2x plus 4. So I'd split it up into 2. So I'd say, well, it's going to be a number on x minus 2, because the thing on the bottom is linear, so the thing on the top must be a number, and then bx plus c on the other one, because the thing on the bottom is a quadratic, so the thing on the top must be linear. Then, and I'll just think about the top only, just because I'm lazy, essentially. So x squared plus 2x plus 4 plus bx plus c times x minus 2. And then I compare, and then I equate the coefficients here with the top. So the coefficient of x squared must be 0, which means that a plus b must be 0. You're on my YouTube channel, Miss Swain. Sorry for that distraction. So that means that a equals minus b, and I know I'm skipping some algebra, but we're good enough to be able to do this. So now the coefficient of the constant, so the constant, I think I just said, is 4a minus 2c, and that must equal 1. And the coefficient of x is 2a plus c minus 2b, which must equal 1 as well. Okay. And I'll stop there, but the idea is that if I replace that there, so that would be, sorry, this isn't great setting out, but anyway, 4a plus c is 1. So if I use that equation and this equation now, I will be able to eliminate a, get c, and then I can use that to get a, and then I can use a to get b. And then I would have a partial fraction which will again be a log plus a log, basically. There's actually one small thing that we haven't talked about that makes this maybe not work. Well, sorry, it does work, but it requires one more technique, which, if you remember the failed quick quiz question 1 yesterday, is basically that. But that's something that we'll talk about next term. But yeah, all I'm going to show you at lunch on Monday is just how to decompose these partial fractions. There is a photo of Taylor's cat that I hope you enjoy, and I'll see you Monday lunchtime. Oh, and please keep doing those harder 3-unit polynomials questions for Monday.